Hey everyone, thanks for joining Data Engineers Lunch. We'll give everyone a couple more minutes to file in and then we'll get started shortly. Everyone, welcome to Data Engineers Lunch. We'll give everyone another minute or so to file in and we'll get started shortly. Alrighty, let's go ahead and cut the music. Hey everyone, welcome to Data Engineers Lunch number 65. Today's talk is going to be on JanusGraph on Jupyter and using notebooks with graph. Today's talk is going to be given by Ryan Quey, who's an engineer here at Anant. Co-organizers for this event are Rahul and myself. If you are interested in giving a talk at Data Engineers Lunch or Cassandra.Lunch or Sister Lunch, feel free to reach out to me. My email is listed below. Also, if you're interested in sponsoring Data Engineers Lunch or Cassandra Lunch, feel free to reach out to me as well. We are a part of Data Community DC. Data Community DC believes in building an inclusive culture. So no matter your race, gender, or sexual orientation, everyone is welcome. And we expect the respect to be given to all. Data Community DC is built up of a bunch of different organizations. This event, Data Engineers Lunch falls under Data Wranglers DC. So if you're interested in all the various organizations that fall under Data Community DC and all the various events, you can find out more at datacommunitydc.org. So what we cover here at Data Engineers Lunch, we cover everything from the ingress to egress of data. So from data in to data out, how we manipulate, how we transform, how we clean that data, and all the various tools and processes that are in the ecosystem. So there's a ton of stuff to cover here. So again, if you want to learn something and then give a talk about it, feel free to reach out to me, as well as if you've worked on any of these processes in the real world and you want to talk about it, feel free to reach out to me, as well as if you have a tool that you're a part of or you're building, feel free, if you want to show it off at Data Engineers Lunch, feel free to reach out to me as well. Group rules, if you have a question, go ahead and ask it. The speaker may have preferences, and when they prefer questions, either in the chat or if they prefer you just to speak up, they'll cover their preferences when they take over. But obviously, please be polite and courteous to others. And this is meant to be a community, so please do share what you know with us. Or if you want to learn more about something, feel free to ask questions. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us. DataStax is a partner and a sponsor. GW University also helps provide venue space when we have in-person events. We also have some organizational and institutional sponsors. If anyone is looking for a job or is offering any jobs, feel free to drop links and we'll get them sent out to YouTube as well as Zoom. Or if they have any meetups, hackathons, conferences, summits, etc., that they would like to promote, feel free to drop those links as well and help get them spread. DataStax Astra currently has a build-a-thon that's ongoing. The third month is currently ongoing. So if you're one of the top 3 winners for this third round, you can qualify to present on demo day. So there's cash prizes to be able to be won on the individual rounds as well as the demo day. So feel free to check it out. Anant is hiring. If you're looking to be a full-time or part-time data platform operator, engineer, or an architect, you can find out more at careers.anant.us. Again, all of these lunches happen every Monday at 12 p.m. Eastern. We are looking at having a more variable time slot to cater to a more worldwide audience. Same thing that goes for Cassandra Lunch, which happens currently on Thursdays at 12 p.m. Eastern. As well as we've recently released our second Apache Cassandra runbook through Anant. So this second runbook's more about Cassandra data operations. So it falls into that realm of data engineering. So if you work with Cassandra or Spark, this runbook can be helpful to you. So we'll drop the link below. It's free. All you need to do is fill out the form and we'll send it over to you. And with that, we will go ahead and pass it over to our speaker for today, Ryan.
Cool. Thanks, Arpin. Yeah, so my name is Ryan. I'm working with Anant and as a data engineer. And today I'm speaking about Graph Notebook, which is a project put out by the AWS team. Yeah, and so for me, just if you have questions or whatever, just jump in and participate. Feel free to turn on your camera too if you like to. I mean, of course, no one has to, but yeah, just make it more interactive. But yeah, up to your personal preference. So let me share my screen. Okay, so today I already wrote a blog post, so I'm kind of just, this is kind of the link here. I'll just post it in the chat. But the idea is, if you want to read more or look at it more, you can kind of go here. And I wrote personal notes on kind of how to copy the steps to get set up and everything in the blog post as well. So so let me just let me just post that in the Slack if I can figure it out. Okay, here we go. Not the Slack, sorry, the chat. And yeah, so the idea is just JanusGraph on Jupyter using notebooks with Graph. So one, there's a couple of reasons why this is kind of a good fit. Jupyter with Graph, particularly with Tinkerpop and Gremlin. First of all, because Graph itself is naturally built to be visualized, and that's kind of the big selling point for using Graph in the first place. They call it whiteboard friendly. You think of your data model, and if you're used to a relational database, then you have to take that data model and turn it into tables and so on. With Graph, it lends itself more to, of course, you still have to focus on your data model and how you want to design your nodes and edges and so on, but it lends itself more to what you drew on the whiteboard is how you design your data model itself when you're putting together your schema and so on. So it lends itself to visualization, and so and a notebook helps to facilitate that. So when you have a notebook, and I haven't opened it up yet, but when you have a notebook, you can play around with it, you can visualize it, and that's something that in particular this project does. The graph notebook tool put out by the AWS team. So that's one reason why it's a good fit. The other reason why it's a good fit is Gremlin is a little bit obtuse. If you've ever tried looking at the syntax of it, there can be a learning curve here. I opened up one guide here. It's kind of a common one by Kelvin Lawrence. And if you look at here, let me just if you look at like a sample query, it can get a little bit hairy. You're like, what's an unfold? What's a value map? You know, it can be a little bit less intuitive even than SQL. So on the one hand, the data model, it lends itself to visualization. On the other hand, the queries themselves, they can be a little bit difficult. There's a little bit of a learning curve. And something that people appreciate about notebooks in general is that it helps lower that learning curve, making it easy to get set up. So with that in mind, I just wanted to explore this project for myself, the graph notebook tool, and it's just, oops, that's not the right, this is my repo. Okay, oops. And I'm didn't put a link of it here, so I'm just gonna, yep, JanusGraph notebook. You can just kind of find it here. So this is kind of the main project that I experimented with and put together, just a quick demo to get it up and running on JanusGraph in particular. So JanusGraph is one graph database that implements Tinkerpop, that implements the Gremlin queries. And what Graph Notebook does is it just, any graph database that supports Tinkerpop, OpenCipher, so Neo4j, or RDF Sparkle graph models can be used in Graph Notebook. I've only tested out the Tinkerpop one, and again, I particularly with JanusGraph because it's open source. But yeah, so that's kind of the Graph Notebook idea. And what they did is they put together a whole bunch of sample notebooks, and it's made by the AWS team. Okay, so out of the box, it's going to work best with AWS Neptune, but it can be used for all kinds of different, graph databases. So this is what I was using, yeah, with JanusGraph. So yeah, in general, as data engineers, we know we like best practices, and someone might say that a best practice is to not do a live demonstration with your code when you're doing, a live stream, but here goes anyways. I feel like this way we can kind of, if we run into an error, we can at least work through it together. Okay, so I don't have anything running. I just I do the git clone, pull my repo here. I can post a link to the repo that I put together for this in the chat as well, if you wanted to follow along, or yeah, where's my chat? Here we go. If you want to follow along. And so yeah, I just can go in here, do Docker, and it should just work. Docker compose up. Okay, so it's starting. And for this particular setup, I did include an, oh, well, there it goes. I did include, here's my Docker compose file. So we've got the Graph Notebook service. This is the Jupyter notebook itself, the Jupyter server. You have the JanusGraph, the main, JanusGraph database, and JanusGraph requires a backend. So for this, I'm just using Cassandra as a Cassandra backend to store the data itself, and then Elasticsearch to do the indexing. We're not going to look at the indexing today, and I didn't even implement it. But you could easily just set up your own indexes and put it in Elasticsearch with this setup. Yep, and it goes there on the network there. So, okay, so it looks like it's up and running, and yeah, so to get started, yeah, okay, so you do your Docker compose up, and then we need to load some seed data. So, okay, let's see. The Janus. Okay, so Jupyter's up and running. You just put in your password. By default, it's I forgot what it is. By default, the password is here, TensorFlow. Okay. Okay, so the Graph Notebook team put together a whole bunch of sample notebooks that you can play around with. Unfortunately, a lot of them require, like if you look at it, they have this great little seed step. Maybe this one doesn't have it, but a lot of them have like a seed step where you just run this one, notebook cell, and it and it gets all this seed data loaded up into your database. Unfortunately, with the way that JanusGraph works, JanusGraph doesn't allow custom IDs, and this seed data requires a custom ID. So this doesn't work. But you could do this one, for example. This one works because it's just a query. What I did is I just found, well, one of their sample notebooks. Okay, leave this. Okay, one of their sample notebooks is the air routes one, and it was built by, again, Kelvin Lawrence. He works at the AWS team, and he has a great guide, and he works closely with the Tinkerpop team overall, or the Tinkerpop project overall. And he posted his data set online. So there's just like a quick, I just made a script and put it in the repo. So just going to do that. So it's just downloads the file, the data file, and then copies it into the notebook container. So let's just run that. Okay. So it's just a bash script in the repo, and then copying it in. Okay, so now I've got the file. I've got this airouts XML file in my container. So now using this XML file, I can load that XML file into the graph database. Okay, so let's just start up a Gremlin shell, Gremlin console. Okay, set up my Gremlin remote. Okay, set up the traversal source using their properties. Okay, and then this is doing taking that graph traversal source, running the IO step, taking this path, so the path is just here, this XML file that I just copied into my Docker container. It reads over the file, iterates it into the database. So I'm just going to copy that in. Again, let me know if you have any questions or anything. But so this will take a second. So this is loading all that XML data, and we can just like take a look. What's that XML data look like? I think it goes here. Yeah. Okay. So it's just yeah. So here's a node. Here's the XML data. The label of this node, which is a vertex in graph term, we have a vertex and edge, right? So the vertex is an airport. The airport's got a code. You know, this is the airport code. If you've ever flown to the Atlanta airport, this is the code. City, Atlanta, description. Okay, pretty self-explanatory here. And this is how many runways it has. Okay, so here's some data. Here's another airport. Okay, so this is what it looks like. So it takes this XML, it loads it in. Okay, looks like we're done. Let's test to see. So I'm taking my graph traversal source. I'm finding all the vertices, but I'm filtering it. I'll just, it's a small diff data source. Okay, if you're using big data, don't do this because this is going to try to find everything, but we've got a fairly small data set, so this is okay. I'm just testing to make sure it works. Okay, we've got 3,619 vertices inserted into our database. So yeah, now there's different ways we can play around with it. We have a question. Does JanusGraph have limitation in terms of what data format type you can import with? Answer is yes, but I mean, you can transform it into what you need. And there's different ways to load it in. So yeah, your question is specifically JanusGraph. Like if you were using, for example, DataStax Enterprise Graph, they have their own tooling to load data in apart from just the graph IO step. But what we can do is Gremlin IO step. We can look at their enormous documentation page. And I think I just, yeah, okay. So there's different formats that the IO step takes. And the IO step, the basic idea is it's for importing and exporting data straight in, and you can use GraphML, which is XML, GraphSun, JSON, and Cryo, which is cryo data, I guess. Yeah, so it's another data format, and it's formatted. It just takes a certain, format. So GraphSun is not exactly JSON. It's got its own specific specification. Maybe add some more details, but that's the general idea. So good question. Cool. Okay. Yeah. So we've got our data loaded in. We can grab for example, let's just grab one, limit one, and okay, there's an ID. We want to find out, okay, so that's the internal ID of this vertex. If we want to find out what are the fields on that thing, we can do value map. Okay, so here we see this first vertex, the first node in the graph. It's got a code YPC. I don't know where that is. Nora, I'm not. Yeah, it's in CA. Yeah, I'm not sure what that stands for. But okay, so there it is. That's the airport. You could find more. And there's all kinds of queries you can do. But that's just kind of just to get a feel for where our data is. Again, the data is in Tinkerpop, and here we're accessing it using the Gremlin console. But we could also access it, for example, using SQL shell. So if I do a Docker execute into my Cassandra container, I can start Cassandra SQL, and I can describe my key space JanusGraph, and here's my oops. Here's my schema for that. The data is not going to look pretty, but I can look at, some IDs, or I can look at some edges. So this is the thing in JanusGraph, for example. There's all the edges. You can't like query the data in Cassandra and find, what you're looking for really. There's the 38. You can find out how many edges you have, but you can't really, take this and read it directly. So if you're accessing your data, you're going to want to use the Gremlin console. This is one thing, if you are familiar with DataStax Enterprise 6.8, it's kind of a neat thing that you can query the data using, your Cassandra database directly using SQL shell or whatever else, your Cassandra client. And you can look at the data and you can see your graph edges and vertices from SQL shell or whatever else you're using to access your Cassandra database. So anyway, the data is in Cassandra. We can access it using the Gremlin server. And okay, so the moment we've been waiting for, let's take a look in the notebook. So yeah, if you were just using the notebook, and again, if you're using AWS Neptune, you could just run this and it just loads all the data for you. We did that separately because again, we can't use the custom IDs with JanusGraph. But yeah, he gives a lot of instructions. So this is super helpful, just the way they put together this notebook. They gave all these instructions for getting started with Tinkerpop, with Gremlin queries in general. And then one thing to keep in mind, particularly for Graph Notebook, is they added their own little syntax here to let the notebook know how to perform visualization. Okay, so here this is a shortcut. We'll get into it in a second, but just yeah, they added their own things here. Okay, so let's just kind of run some queries and get started. So yeah, here's their simple example. Oh, okay, I forgot to do something. I didn't set it up right. Okay, so I need to add my configuration to let it know where to run first. And again, I copied my instructions for myself here. Okay, we need to run this first. And basically it's just saying, don't look at host localhost, look at host JanusGraph. Because again, how this works is the notebook container, it needs to communicate with the JanusGraph container. So if I just, by default, sorry, let me go back. By default, it's trying to connect to host change me. Okay, that's not going to work. I needed to connect to host JanusGraph, taking the container name, the JanusGraph container name. Okay, so let me try again. I'm just going to paste it here because why not? And let me see. I might not need to restart the kernel. Great. Okay, there it goes. So now we're connected and we get a little graph. Okay, cool. So what's happening here? Here's the Gremlin query. And again, we can take this same query and copy it and paste it into our Gremlin console. And it should work. that didn't work. Okay. Well, it should work. Let me see. Code as code by value map limit 5. What happened here? Okay, so the path works by value map. Okay, so I wonder why limit 5 didn't work. Okay, not sure. Well, it should work. Or I guess it shouldn't work, but yeah, I'm not sure why. Anyways, moving on. Live demo. Okay. So the idea is you can take this. It's taking a query. You put it into the cell, and you're using the magic gremlin here, and then you can create a visualization. So you can see the data as it comes out. And here he has, they use limit 5, so there's only 5 entries, and it's equivalent to what we have up here, right? So you can see query metadata right out of the bat. So you can, it tells you how long the execution time was and everything. So, and then yeah, here's the visualization. And how does it know what to visualize? So visualize is it's taking this. Okay, so this is a shortcut. It's saying the path that we're running is a vertex going to an out edge and then going to an in vertex. So here, if you're following the traversal, this is grabbing a vertex, then it's going to an out edge, and then it's going to an in vertex. So that's just telling you this is what the path is. The path is a vertex followed by an out edge followed by an in vertex. Again, if we look at our console, that's what's going on. We have a vertex going all the way to where? Here, okay, vertex followed by an out edge, okay, followed by the in vertex. Okay, so that's, so the graph notebook knows, okay, if it has this and it sees this kind of path, it can make this kind of visualization. It's grouping by country, okay, and it's taking these labels, this label, and using that. Okay, so this is the in vertex, taking the out, the out edge, and then the in vertex. So this is a route from London, goes to Boston. Another route from London goes to Baltimore. That's I assume that's in miles, 3,622 miles. So, okay. Yeah, so it's kind of neat. I think, again, you can, this is kind of just, you get a feel for a little bit of the power. You can visualize what's going on in your query. If you were just to look at this, it's a little bit hard to read and it's hard to know what's going on. If you're able to visualize it, then you say, oh, okay, I can see what's going on. This query, it's starting with the vertex, it's going out the edge, finding all the different routes that leave London, and then it finds what airport it's going into. We could, we could change this. We can change it. Or like, for example, if we want to see what code it is rather than what city, we could do this, and let's see if it works. Okay, in the visualization, okay, so now it's showing me what code, the airport code instead, because I put that in the hint, okay, the airport code. So this is not, again, this part up here, this is not Gremlin. This is just for a graph notebook. That makes sense. So it's saying, okay, for the edges, show the distance. For the airports, or yeah, for the vertices, show the code. Okay. Yeah, so it's pretty powerful. You can visualize your data. You can go beyond limit 5. You know, if we want to show 50. Okay, so here's all the different. Okay, I mean, let's move it back so it's just easy to see. So here's a whole bunch of, routes leaving London, going to all these different places. Okay. Cool. So, what are some other queries? So he says, for example, you can do this. You can rewrite the query to generate a path populated by element map results. Okay. There's some other ones. Okay, let's just kind of move forward here. Okay, so here's some more interesting ones. Okay, here, let's do this. Okay. So here you can use the details. So if you want to find out more about a certain node, you can click on it by using this details panel. Again, if you've tried using DataStax Enterprise, and for me, that's what I'm comparing with. That's kind of have a little bit more experience with. If you've tried using it, I think DataStax Enterprise Graph, their DataStax Enterprise Studio, it looks a little bit better. It's been around longer too, as far as I know. So it's had time to clean up and everything. But this is all open source, which is a big plus. And there's some capability here that, as far as I know, is not also in DataStax Enterprise. But so DataStax Enterprise can do all this as well. But yeah, this is kind of helpful. Okay, so the question in the chat, if you were using Neo4j, what would be a use case for using the Graph Notebook over Neo4j browser or Bloom? That's a good question. I actually haven't experimented as much with Neo4j browser or Bloom. I don't know if any of you guys have experience, maybe you can chime in and see just from what you've seen from Graph Notebook and Neo4j browser or Bloom. I guess one thing is there a notebook that you can use with Neo4j? I'm sure there is, right? There's got to be some sort of notebook. But yeah, if there's a notebook with visualization, I'm not sure. That would be one thing. This is a little bit different in that it's a notebook. But yeah, it's a good question. If anyone has any input, feel free to chime in. I guess another question. I'm not sure if do you know if Neo4j browser or Bloom is at open source as well? Let's just see if it's got a GitHub. Oh, okay. So it looks like it is. Yeah, cool. Yeah. I guess I'm not sure. It's a good question. I'm not sure why they obviously took the time to use OpenCipher, probably because AWS Neptune. I'm guessing that AWS Neptune can use OpenCipher. That's my guess. Yeah. Okay. So that's probably one reason why they support OpenCipher in Graph Notebook. But yeah, good question. So that's a point. OpenCipher is not just Neo4j, and it's open, right? So there's other graph databases that support it as well. And I'm not sure if I guess that's an open question if anyone else knows if Neo4j browser or Bloom do as well. Yeah, so okay. So that's the details. You can you can do different things in the visualization. You can change the color. So here it's colored by what are they doing? I think they're coloring by country code. Okay, so different countries here have different colors. How long are the routes? You can get more complex queries here. Just to explain briefly, this is it's saying find a vertex that is an airport label. So that'd be a node, right? Again, it's a node with that is an airport, and it's got the airport code of CZM. So as we'll see, the starting point for this traversal CZM goes out edge route. Okay, it tucks that away as letter A, goes in through the vertex. Okay, so that ends up here. Then it orders it, selects that vertex by the distance. Okay, and then does the path by code and distance. So here this is. So we have, this kind of makes it clear. You have the original airport, and then it's ordered by distance. So you can kind of see how it's ordered by distance here, starting from 36, going up to 1878. And then in the path, it gives you the airport code, distance, airport code. Vertexes get the airport code, routes get the distance. So, yep. He's got some more complex ones, which are kind of cool. Let's just kind of run all of them. Why not? And then we can just kind of look at the end. Okay, so okay, so here's routes starting in Austin, going to Wellington. So he says, find them all. Give me the simple path. As in just, yeah, not giving duplicates, if I remember correctly, is simple path. And keep on going for a limit of 5. So if the route is longer than 5, just stop there. But if there's like between 1 and 5 hops to get from Austin to Wellington, give that route. And wait, until, I think that's what it is. I think, or maybe it's only 5 routes. Okay, maybe it's only 5 routes. I was wrong. Until, I guess, in this time the repeat keeps going forever. Limit 5. So if we put in here 50, we're going to get a whole bunch of routes. It's going to take a second. It's actually going to take a while because yeah, it's trying to find. This will keep on repeating, saying no matter how many times it takes to get from Austin to Wellington, find it. Okay, so let's just do full screen here, and I'll lock it. So if I don't lock it, it's kind of wiggly and it doesn't really help me. So sorry, that probably didn't show up very well in Zoom. Okay, so I'm going to take Austin, put it over here. There's a Wellington somewhere. Oh, here it is. Okay, so you can kind of see this route. Oh wow, this route goes from Austin to all kinds of other ones before it gets to Wellington. So I guess this is the total amount. It didn't get to 50. It looks like. Yeah, there's a. Where can I fly from Santa Fe nonstop? He had one. Okay, so like a larger. Oops. Don't know what happened there. Okay. So you can add some color and stuff. Yeah, I don't know. There's not too much more. There's tons of visualization settings you can change. You could use custom logos, I think below here. Yeah, you could take all country codes for CA and make it, make it red. MX, put a flag. US, put a different flag. So here's the red. Oh, CA Canada. That's pretty. That makes sense. Okay, so red Canada. Here's the America, and here's Mexico. So yeah, yeah. There's not too much more. There's other things you can do. I mean, I'm doing this call from Cambodia, from Phnom Penh. So in the blog post I just made it kind of like this, and I had to drag it around to make it go from here. So, but if you group by country, you can see here's Phnom Penh. Yeah, let's just do this. First, I'll reset the settings. And I think this actually needs to go in a separate cell. Okay, so I got my node labels. Okay. So what is this doing? It's starting with the vertex, starting from Seattle. That's kind of where I'm from. So repeat, it says repeat, so it keep on repeating and go out from this initial vertex Seattle, go back in and find a simple path. So don't let it go crazy and recursively and so on until it gets to Phnom Penh, PNH, limit of 50, only want 50 results, and get the path for that. So here's the path. So graph wise, it kind of looks like this. So yeah, I already pulled it around in the blog post, but you could take it and you kind of pull it around if you want to, and you can say, oh, okay, here's cities in China, and here's Hong Kong. Oh, I guess they gave Hong Kong a different color than China in this one. Tokyo, Seoul, and you can kind of see, oh, okay, so here's the distances, here's the different routes you can take. Most of the time when I'm flying, it'll go through, yeah, Seoul or Tokyo, or there's not really any direct flights. So I have not flown through Dubai before, but probably if you're going through the East Coast route, those are probably more expensive flights. Anyway, so this is kind of just a demo. Hopefully it makes sense. Overall, from my experience, just by way of just as like a, my personal take on the Graph Notebook. Again, a big plus is you can use it in open source. So DataStax Studio, it seems like if I were to use, at least at this point, pick one or the other, Jupyter, like a Graph Notebook or DataStax Studio, probably just use DataStax Studio. It works out of the box. It's, at least from what I could tell, it has everything that I needed. But one big strength for Graph Notebook is it works with open source. So for JanusGraph, it worked great, and setting it up worked fine. And it just adds a lot of functionality that makes it a lot easier to kind of get up and running, get started. If you have a development team and you develop, kind of want to let your developers play around with different queries, this would just be a great way to do that without having to use DataStax' proprietary software. So just, yeah, again, I'm comparing with DataStax, not for any particular reason besides just that's kind of what more of my experience is with. But yeah, that's kind of the gist of it. Did you guys have any questions or things that caught your attention regarding Graph Notebook or JanusGraph or Gremlin?
I just wanted to say that looked really cool. The output, the graph output was really easy to parse, and being able to click and drag it like that seems just very functional.
Yeah, totally. They did a great job with this. I'm happy it's put out there, and I think, yeah, again, one of the big issues with Gremlin, I think, is the learning curve, and hopefully this and there's other tools that seem like they're coming out more and more will help with that. But yeah, cool. Thanks for that
So I
feedback.
have a question. Have you tried any sort of scaling tests? Like how big does this allow for? Or it does at some point, does a Jupyter notebook keel over on its head?
Yeah, good question. I haven't tried it with more than just the sample data set that was there. That'd be a good question. I know DataStax Enterprise Studio, I think they limit it to 1,000. What would it be? Would it be 1,000 nodes? I can't remember the exact number, so don't quote me on that. But they do put a limit on it. I don't know.
Yeah, because I mean, I know we got customers running tens of billions of nodes within JanusGraph, and so I'm
Yeah.
just concerned about, like, would suddenly your page just die? Would your browser just keel over, right?
Probably. I mean, either they put a limit on it, or yeah, or you would have to put a limit on it, right? As in, like, just make sure in your query don't get too crazy and try to grab everything.
Yeah.
It just wouldn't work. And then it wouldn't even be visual. Like, you're looking at it and you're like, there's nothing I can do with this visualization because it just
It could all be like black everything everywhere, lines
yeah.
everywhere.
But yeah, it's a good question. I'm not sure. I don't know if there's a limit or I don't know. I'm not sure.
Yeah, I mean, that tends to be the thing that happens with graph databases is complexity often capitates like performance will capitate the complexity of the data model. Yeah.
Right. Yeah, and yeah, I wouldn't want to grab all that data from a query, generally speaking, anyway. But yeah, it's a good question. I wonder if they put some sort of limits in the JavaScript or something just to make sure that they're not blowing up your browser. Whether or not your database blows up, and then make sure at least that the browser doesn't blow up. So I'm not sure. Yeah, good question.
Thanks.
I guess we can try one thing at least. See if it blows up my browser, huh? Okay, so it grabbed all the entries, and it shouldn't. I don't know if they'll even. Okay, it will try to visualize it. Okay, those are all my vertices. Yeah, if it logs me out, you'll know what happened. So yeah, it's going slow. I'm clicking right now. It's not going. So
Sorry for ruining your demo at the end there.
no, yeah, it's good. Oh, okay. Well, it doesn't like it. Chrome's
Boom, exactly.
complaining before the graph notebook is. So yeah, not sure about that one, but it looks like 3,000 nodes is probably more than you're going to want to do.
All right, good to know.
Close that. So cool. That's probably a good place to stop after I blew up my browser. So, but
all right.
good
I just
question.
want to thank everybody again for joining us. Please like and subscribe to our YouTube channel if you haven't already. And we'll see you again, same place, same time next week. Take care, everybody.